just because. What problem was that, Matt? 12? Yeah. Again, people, a net just means you have this box and you're unfolding it to see what it looks like when you unfold it. And this one's not too bad. It's just going to be, you've got your starting outside triangle, which is this right here. And then you've got this piece right here connected to it, which is what shape? A rectangle coming out. It doesn't like that part. No. You got that rectangle coming off it like there. What's connected to the bottom here but another rectangle that goes like this. And there's a bunch of different ways to do this. What's connected on here? Another rectangle. That gives me the three sides. See if I can find that in here. That gives me the three sides. That gives me this, this, and this, and then the only piece that's left is you have to have the other triangle that's on the back, and you could connect that to any side. You could connect it here and it look like this, connect it here and it look like this, but you can only do it once, so take your pick. But that would be, if you fold it on all those lines, you're going to get that triangle prism. Now, number 10. What was the size of your starting square? Jacob?
I put 10.
Alright, that's a good start. This is a pretty simple one, actually. Jake says, I'm going to draw my own square. It didn't tell me the size, so I'm going to make it a 10 by 10 square. If the sides are increased by a scale factor of 2, your new square is going to be what? Scale factor of 2 makes this 20 by 20. And then what are your areas? It's pretty simple multiplication here. What's this area? 100. What's this area? 400. Okay. Now the question is, here it is. The area of the larger square, 400, is what percent of the area of the smaller square? Now, this, children, this is what fraction. If I reduce that, what fraction do I actually end up with? 4. It didn't ask me for the fraction, it asked me for the percent. So you need to know that 4 is what percent? Huh? What's 1 is what percent? 100%. So 4 is 400%. I mean, you could probably make the fraction, you could make the fraction box out of it. You could say 4 over 100 is what number over 100, which happens to be 400. Okay? But you needed to do this part at the very least, which only makes sense. The one. So on tomorrow's test, you're probably going to have to do, it's going to be kind of that same deal. Change your fraction into a percent. Sam?
Number 1.
Number 1. Number 1. Right away, as soon as I see 3 out of 4 doctors, guess what I'm going to do? I'm not even going to read the rest of the problem. I'm going to do this. I'm going to write me a ratio box. You're in 7th grade. So what are we comparing?
Survey.
Well, doctors who recommended to doctors who did not recommend, and that's going to give you some sort of total. I don't even know what the rest of the problem is. I'm just writing that down because that's what I can figure out. Recommended, not recommended, and total. 3 out of 4 doctors surveyed recommended it. So where do those numbers go? Is it 3 doctors recommended, 4 didn't recommend it? 3 doctors recommended out of a total of 4 doctors? Where does it go there? Luke?
The 3 goes on like the recommended and 4 goes on the total.
Right. 3 out of a total of 4 doctors. So that means 1 out of those did not. So they have to add up. 60 doctors did not recommend the product. 60 did not recommend it. Goes in the did not recommend box. How many doctors were surveyed? It doesn't get too much easier than this. You know, you can make your fraction. 1 out of 4 equals 60 over what number? But you can see it right here. How do you go from 1 to 60? Multiply by 60. Multiply by 60. That's where the 240 comes from. Eli? 5? 5? 5. During the season, a basketball player made 24 out of 40. He made 24 out of 40 free throws. What's the probability that the player will make the next free throw? 24 out of 40. Just reduce it. Okay, this has to be experimental probability. You can't figure this out theoretically. You can't write a mathematical equation because you can't do that based on somebody's skill. You just have to go by what already happened. And what happened? They made 24 out of 40. So the probability is, when you reduce that down, 6 goes into it, 4 goes into it, 6 over 10, which reduces down to 3/5.
Yeah, I looked in the book and it said to
Change
check
it.
the decimal.
Oh. If you have 0.6, I certainly wouldn't mark it wrong if you put 0.6 down. But use your probabilities fraction as a rule when the book does it. I don't know what they were thinking there. Grace?
I don't understand number 6 and 7.
6 and 7? And those would be things that you would have on your notes. Okay? First things first, area of parallelogram. Area of a parallelogram, if you look in your notes, is simply what? Area of a parallelogram is just base times height. You have to pick out what you want of this because this is not a, they give you more than a parallelogram here. This is actually a trapezoid, it's a triangle, it's a quadrilateral, it's whatever. They told you A, B, C, D. A, B, C, D. This is your parallelogram right here. They want the area of this. Okay? You don't need to worry about the triangle part that's there. That comes in a little bit later. But when we talked about this, base and height have to be what? In order for something to be called base and height, it has to be perpendicular or form a square corner. So the next thing I look at here is where do they give me a square corner? Because the book will have to give you a line that has a square corner on it, and it's right here. The two lines that form this corner are your base and your height. Well, one of them I know is 12, and the other one, if I come across here, is also 12. It is 12. I mean, you could, if you want, you could take this dashed line and just move it right here. It's the same dashed line that would be right there. Base, height. You'll get the same answer there. So the area is 144 inches squared. Who's my squeaky chair person? You could stop if you like to get another chair. Just saying. It really comes up loud on the camera. Now, the next one, Grace, said 7 too. Area of a trapezoid is what? 1/2 of base 1 plus base 2 times height. And when it comes to trapezoids, Emily, how do I know what my base 1 and base 2 are?
It's the ones that are parallel.
Exactly. Now I'm looking at this whole shape right here. It's the whole shape, the trapezoid. And the ones that are parallel are this 12-inch line and this whole line down here, which you have to do a little math to figure out. 12 inches plus 10 and 12 is 22 inches. Again, though, the height has to be perpendicular, so the height is still going to be that same 12. Doesn't really matter the order you do this. I would add these together first and get 32 times 12. You can take half of 12 and get 6, and then 32 times 6 is 192. Whatever that is, inches squared. And then we might as well do 8 while they're talking about it. 8 asks for the area of a triangle, and the area of a triangle is just 1/2 base times height. And again, those need to be perpendicular. So here's your height again. Height is 12, base is 12. 1/2 of 12 times 12. Half of 12 is 6. 6 times 12 is 72 for the area of your triangle. Did I do something wrong?
Yeah.
Oh, what did I do wrong?
Who? Is 32.
Oh, sorry. 34. So that's 17 times 6. No, what? Oh, 6 times 4. So this is actually what? 194? Or 204. 204, sorry. I did that just to check and see if you're paying attention. 204. Believe it or not, if I took these tests, I would probably get at least 1 wrong than everyone. Just the way it works. Did I still do something wrong? Christine? Somebody still stuck on this one?
Yeah, for number 8, you said the answer was 60 inches squared.
What did I say?
You said the answer was 60 inches squared.
I think I said 72. Thought I said that.
Yeah.
Was I right on that?
For 8, it is 60.
Yeah.
Oh, you know why? Because I looked at the wrong triangle. I was doing this thing here. It should be 10 times 12 cut in half. Again, just checking to see if you're listening. So half of 120 is 60. I told you I'd get at least 1 or maybe 2 on this one. Christine, number 2? 3. Maybe the best way to do this one is still a ratio problem, percent problem, however you want to do it. Okay, you're comparing what? Minutes into hours or whatever it is. You know that 5 minutes is how much of an hour? 5/60ths. And you want to know what percent that is, right? So it would be 5/60ths is what number over 100, because percent means out of 100. 5/60ths is what number out of 100. You could reduce that, and I know most of you did. 1/12 equals what number over 100? So you end up cross multiplying and getting 12, doesn't like this spot, 12 n equals 100. And if you take 12 into 100, what do you get? 100 divided by 12, 8 is 96. What do I do with this leftover 4? Make it a fraction. Make it a fraction. 4 over 12 is 1/3. 8 and 1/3%. I would probably give it to you if you did 8.3%. That would be up as well. But, 5/60ths is what percent? Is what number over 100? Great.
I don't understand number 14.
14 children. You know what? We'll skip 14. 14 is the Pythagorean theorem. Because if you took any triangle that they did there and took a squared plus b squared, you'll always get that c squared thing. But just skip 14 for right now. I concur on that
We
one.
don't have to do it on.
You won't have to do it on
Yeah.
Can we do it for extra credit?
No, it'll be the Pythagorean theorem tomorrow too. So, Gary.
What, I don't get why I didn't really
Nor do I at this point. The important thing to see on problem number 11, ladies and gentlemen, is this word right here. Square and square. If it asks just to change 54 feet to yards, that's easy because you just figure out how many feet are in a yard, blah, 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 blah. But the word square changes it. 54 square feet means this. 54 feet squared. What does a squared thing do? It means you have double of the label, not double the 54. So I have 54 feet times feet. And if I'm using unit multipliers to change that into yards, because they're doubled, I need double unit multipliers, because I need one to cross off with one label and the second one to cross off with the second label. You just need to know how many feet are in the yard, which is 3. Your feet cross off, and you're left with 54 times 1, which is 54, over 3 times 3, which is 9, and 9 goes into 54 6 times. What label is left? Yards times yards, which is our yards squared. Did some of you just get 18? If you just got 18, you ignored the square part of that and you just changed normal feet into normal yards. Square means squares. There's double. 2 labels that you have to do. If it was 54 cubic feet to cubic yards, that means the same thing except you have to do it 3 times because there's 3 labels. Yards times yards times yards. Feet times feet times feet. Eventually that'll sink in. Maybe not today, maybe not tomorrow, maybe not when you're 74. But probably by the time you're 75, somebody will get it. Smith?
19 and 20.
Well, did you do the first step and find factorize it? And what'd you get? Let's do 20 first. The square root of 18. And again, people, do not skip and get lazy on this and not write the radical signs when you break this down. 18 breaks down into what, Smith? The square root of 9 times the square root of 2. And then what? You're not done yet because the square root of 9 breaks down into the square root of 3 times the square root of 3. These are all prime, so you can stop with them. Rewrite them over here. You get the square root of 2 times the square root of 3 times the square root of 3. Now what do I do? If you have doubles, they cross off and you get a normal one. So a double 3 gives you just a normal 3. There are no other square roots of 2, so it just stays 3 times the square root of 2. Same thing for 3600. You're going to have to prime factorize that all the way unless you find an easier way to do it, but it's the same spiel. You're going to get a bunch of things. There is a lot of things if you will. Jacob?
Number 17.
Yep. How do you do division when it comes to scientific notation?
Well, I know that, but it's like,
Well, first things, you divide these two things.
Yeah.
1.2 divided by 2 is 0.6. Then I get times 10, and here's where you have to be careful. When you multiply scientific notation, you add exponents. When you divide in scientific notation, you subtract exponents. Okay, but here's where it gets really kind of dicey. If I subtract these exponents, I take 5 and I subtract a negative 2. When you subtract a negative 2, it's actually adding 2. 5 minus a negative is actually 5 plus 2, and you get a 7 here. So you have to be careful with that. Now, why is that not the answer, Peter?
Because you have to move this.
Because it's not in scientific notation anymore. This number has to be between 1 and 10. So for that to happen, I need to move the decimal one place this way. It becomes 6. And then here's another part where people get confused. Because I moved that decimal, my exponent changes. I moved it one place. Does it go one up or one down? And how do I know? Is my answer 8 or is it 6? And why? Kevin?
Up,
Why does it go up?
because you're changing it, because it was 0.6, now it's just 6. So the answer is wrong.
And here's what you need to think about. These have to balance each other out. I made this one bigger. This has to be one smaller. So this should be a 6. They balance each other out. You adjusted this, you got to adjust this the backwards way to give them the kind of balance out there. Bam!
18.
18, my favorite of all. 24x cubed y negative 1 over 16x squared y squared. Alright, we have trouble with the numbers, reducing those? What number goes in 24 and 16? 8. So you divide this by 8, you get 3. Divide this by 8, you get 2. Now, what about the letters, though? Okay, as long as they're positive, you don't have too many issues. If I have 2 x's on bottom and 3 x's on top, what's going to happen? They cross off 1 for 1. 1x crosses off with 1x on top. A second x on bottom crosses off with a second x on top. Still got an x left there that didn't cross off, so it has to stay. And then what about these y's? Grace?
You take the y negative 1, you bring it down, and it just becomes a 1.
Right. We don't deal with negative exponents, so I need to change this and make it a positive exponent simply by putting it on the bottom. So now I have y squared, and another y gives me a y to the third power. And that's what you're left with. 3x was left on top, and 2y cubed on the bottom. And that is the most simplified that you can get with that at this point in your mathematical career orders. Michael?
I didn't get number 2.
Number 2. Alright. Everybody know what I'm going to tell you on number 2?
Ratio.
It's a markup problem. It's a ratio box. When you see this, this is what this looks like. Okay, you have your original price that the store buys something for. Then they mark it up. They add something to it so they can make a profit. Otherwise, they won't be in. If a store sold you this whatever for the same price they bought it for, they're out of business because they got to pay their bills. And then you get your final price here. And our original percent is always 100. How much did they mark it up? So their final price is 100% plus the next 40% is 140%. Now, where does 4,000 go? Is that how much the final price was, or is that how much they originally charged, or how much they originally bought it for? Where is that? Jacob?
The original.
Right, so 4,000 goes here. And that's a good number because, people, it's easy to go from 100 to 4,000 because you just need to do what? Multiply by 40. Everything on this box gets multiplied by 40 to get to this box. 40 times 40 is 1,600. 2 ways to find the final box. You can either multiply this by 40 or add these two together. So it'll give you the same thing. 4,000 plus 1,600 is 5,600. So that works out. So you should smile when it's something that works out that nicely rather than doing it wrong. You can do the equal fractions, you'll still get the same thing, but it's just kind of nice. Loops.
I didn't get number 4.
Number 4. Factor, anytime they ask you to factor a two-term thing, you gotta think this. Oops. You need to think, I'm going to do reverse distributive property and take something out of these two and put it out there. What do they have in common? If you look at the numbers, it doesn't really, you can't take a number out because 2 and 3 don't have anything in common. What about the letters? They both have an x, 1x. This one only has 1, and that's the most you can take out, so you gotta put that x out there. If you take that x out, I'm still left with the 2, and I'm still left with 1x there. If I take this x out of the 3x, I'm left with just a 3. And that's the most you can factor out of that lovely little thing there. You gotta be close, aren't we? Nobody on number 1? Why does number 9, why is it not direct variation for number 9? Proportion, direct variation, why is it not direct variation? Gary?
It doesn't go through the-
Right, it has to go through the origin and it has to be a straight line. And it doesn't go through the origin. Alexa,
Oh, wait, that has one.
Alex?
13.
What is number 13? A formula for the following sequence is that, find the 50th term. Whatever number, Alex, they give you is the letter N. So you need to put that in for the letter N right here. And you can put it for the N there, but that's just a label. This says this. When you put that little subscript 50 there, that just says the 50th term is 2 times 50 minus 1. And 2 times 50 is 100, and 100 minus 1 is 99. So whatever number they give you here, just get put into that little formula there. G-race.
Okay.
Switch colors here. Oh, 15, yeah. 15. I'm going to rewrite it over here just so I have it. Somebody 4x minus 5 equals 7. My first step is to do what? In complex equations. Smith?
Like it goes together.
Combine what you can on either side of the equal side. Well, you can't put anything together with the 7 because it's by itself. But over here, 4x minus x minus 5, what can I put together? The 4x minus the x. What is 4x's minus an x? 3 x's. The 5 I can't do anything with right now. That's my next step. Once you've simplified each side like we just did, then you try to get all of your x's on one side, all your numbers that don't have x's on the other side. Which means I need to do what? Sammy? Right. Do the opposite. I want to get rid of this minus 5, so I do the opposite to both sides, which is add 5. So now I have 3x equals 12. And then generally, the last step in any solving of equations is to Evan? Divide out what's in front of the x. Do the opposite. This is times, so I divide. That's times, so I divide. X then is 12 divided by 3, or I'm almost thinking that that's got all that stuff there. Sammy,
We did say number 16.
was that the one that was like number 17?
No, we didn't.
No, we
It was
never did.
Oh, we didn't.
This one.
Yeah, just
We'll still do it just because. 16? Was it this big before? It seems that way. Oh, number 16. X over 4 equals 5.6 over 2.8. Yeah, cross multiplying, you do this times this, 2.8x equals 4 times 5.6. 2.8x equals 4 times 0.5.6 times 4 is, how about 22.4? And then your last step is, just like the other equations, divided by 2.8. And I'm going to guess that all kind of goes into it there. 22.4 divided by 2.8. Move the decimal, move the decimal. 28 into 22.4. Oh, looks like 8. 8 times that is 64. 16, 22. Excellent. What would happen if I cut it in these letters and then shrunk it? Would you be able to tell?
Yes. Listen.
Can you tell?
I can't even see it.
Oh, wait.
I can now.
Yeah, I can see it now.
Yeah, I can type.
I mean,
I can tell it's colored. That's it?
Yeah.